Oops, I don't have me on screen. Sorry about that. Hi, pre-calc, and welcome to 3.2. Okay, this is all about logs and their functions, and we're going to be doing a ton of graphing, transformations, and those type of things, and how they actually work. So make sure you have your calculator out because you will need it, and your notes. So let's go. Okay, we're going to change from a log to an exponential form. We're going to change from exponential to log. We're going to evaluate. In order to find the actual answers, we are going to, here we go. Use basic log properties to expand and compress. We're going to graph them. We're going to do a lot of this. We're going to talk about the domain and the range and the common and natural logs, especially those buttons on your calculator. All right, first of all, how do you write a log from a base form? So when you look at this log and these two, these are identical expressions. They're log base b, which is the base of your exponential, of x. So x is your answer, and equals y, because logs find exponents, which is the y here. So I'm going to rewrite some of these, and you're going to do the rest. So now when you go this, and I have to rewrite to an exponential, 7 is the base, just like always. Logs find exponents, so that's 7 cubed, and that equals x. Okay, try yours. You should have gotten b squared equals 25. Here, it's 4 to the y equals 26. This here's the real reason we use logs when the variables are in the exponents. The only way to get them out. So change from exponential to log base. Let's go backwards. Now, so this is a log, base 2, because this is the base, of x equals my exponent, which is 5. Okay, pause and try yours. So you should have log base b of 27 equals 3. This one's a little tricky. This is log base e of 33 equals y. The only problem is log base e technically isn't a thing. That is always known as the natural log. So it's ln of 33 equals y. This is a button on your calculator. That's why we have to know what this means. These are identical. Natural log means base e. Just like a regular log means base 10. That's known your common log. Okay, here we go. To solve or evaluate, you always set it equal to x, and then we rewrite. So this is 10 to the x power equals 100. Well, we know if we get like bases, our exponents are the same. 100 is 10 squared. Bases are the same, so x equals 2. Okay, pause and try yours. So set it equal to x. So we know 5 to the x equals 1 over 125. We know that 125 is 5 cubed. We need to bring it to the numerator. So 5x equals 5 to the negative third. Since the bases are now the same, x must be equal to negative 3. I hope you did well. Okay, if you did not, try this one again. Set it equal to x, so 36 to the x power equals 6. This time I need to get this side to the 6 power. So that's 6 to the 2 squared times x equals 6 to the first. So 2x equals 1, which means x equals 1/2. Next one, when you did this one, you had to rewrite this here in fractional form. So this really means log base 3 of 3 to the 1/7 power. Set that equal to x. So 3 to the x equals 3 to the 1/7 power. So x equals 1/7. This is actually known as an identity. When the bases are the same, they will always cancel, and the exponent will be the answer. Now let's see how it works. Okay, some basic rules. If the bases are the same, it equals 1. If you have 1 here, anything to the 0 power is 1, so it will always be 0. Bases are the same. We just proved that one above. So you get x, or b to the x equals b to the x. And it is true in reverse. B to the log of b is also equal to x. All right, let's go through and show you how these work. So log 5 of 5, we know this is 1, because anything 5 to the first equals 5. Here, this part is 1, but now it's 1 times 8, so the answer is 8. What 15 to what power equals 1? The answer is 0. Well, this is also 0, but 0 times anything is 0. This here was an identity, so we get 10. And this is also an identity, so we get 7. Pause and try yours. You should have had 1, -5, because this was the 1 part. Anything to the 0 power is 1. 0 times anything is 0. This one's a tricky. I'll come back to him. These are identical, so your identity is 3. Here, you had to do a little bit of work. Log base 2 of 2 cubed. All right, now you have your identities, and your answer is 3. Hope you did a great job. Okay, next we're graphing. Okay, so now let's remember, I have 3 to what power equals f of x. So this is just a straight exponential. So we know -2, we'll write this one out, means 1 over 3 squared, which is 1/9. Well, -1 means 3 to the negative first, which equals 1/3. Anything to the 0 power is 1, 3 to the first is 3, and 3 squared is 9. Now let's graph these. We go to -2, 1/9, -1, 1/3, 0, 1, 1, 3, and 2, 9. If you notice, no matter what number you plug in for x, it will never equal 0. The larger the negative number, the closer to 0 it gets, but it will not equal it. So the x-axis, or y equals 0, is an asymptote. It will approach it, but it won't cross in this case. So the domain is, what can x be? Well, that's any value on the x-axis, because it doesn't matter. I can plug anything in. So it's -infinity to infinity. Range, look at your y. Where does it start? And it starts at 0 right here. And it goes on forever to positive infinity. Asymptote, we already talked about. That's y equals 0, or your x-axis. Okay, now let's look at what a log does. Okay, so the log here, base 3 of x equals g of x. So now I have to get to y. Well, I know that log base 3 of 3 to the -2 will give me -2. So let's just do this. 3 to the -1 is -1, or 1/3. 3 to the 0, or 1, is going to be 0. 3 to the first, or 3, is going to be 1. And then 3 squared, or 9, is going to be 2. Remember, it's equal to all of your exponents, because when you plug them in here, log base 3 of 3 to the -2 cancels, right? Log base 3 of 3 to the -1 cancels. Well, if you've noticed, these have just switched spots. Your x's and your y's have been rearranged. Now, if you remember from our last chapter, that's your inverse. Because right here, if I had this point, -2, 1/9, the inverse is when I wrote it backwards, 1/9, -2. Here, this point right here is -1, 1/3. Well, backwards is 1/3, -1. 0, 1 is 1, 0. 1, 3 is 3, 1. And then 2, 9 is 9, 2. And that's your inverse, or your log function. This is your log. If you look, it's symmetrical over the y equals x line. And now its asymptote is the x-axis. I'm sorry, the y-axis, or x equals 0, because it will approach but never touch. So now let's look what happens to the domain and the range. Well, now the domain of your log function was the range of your exponential function, because it goes from 0 to infinity. X cannot be negative. The range is, what can y be? Well, y can be anything. It can go as low as at once to as high as at once. -infinity to infinity. And this time your axis of symmetry, or your asymptote, instead of y equals 0, is x equals 0, because it approaches x but does not touch it. Okay, try yours. If you graph 1, you should be able to do the inverse for the second. So for x, you can use your table if you want, or you can know what that is. Because if I know -2 is 1/16, -1 is 1/4, 0 is 1, 1 is 4, and 2, so 4 squared is 16. I think that's 16. I can't read real well. You can write those down if you want. 1/16, 1/4, 1, 4, and 16. I actually don't care if you need to write down the table or not. You can do it without that. Okay, so that's it. This is 4 to the x, and our asymptote is y equals 0. And we go from negative infinity to infinity. Now, the log of 4 I know is an inverse, so I just need to flip these points. So this is negative 2 1/16, so I'm going to go to 1/16, negative 2. This one right here is negative 1 1/4, so I'm going to go to 1/4, negative 1. 0 1 is now 1 0. This in here is 1 4 is now 4 1. 2 16 is now 16 2. Graph in your log function, which is the inverse of your exponential. And now your asymptote is x equals 0. Approaches but does not touch. Okay, let's go here. Domain of my exponential. Well, x could be anything. Negative infinity to infinity. Now we realize, since we switched the x and the y, that that is the domain of the log function. So now y can be anything negative infinity to infinity. The range of my exponential is 0 to infinity. Well, now that's the domain of my log, because it can start at 0 and go to infinity, but x cannot be negative. Asymptote here was y equals 0, and on logarithmic is x equals 0. I hope you did a good job. Okay, let's worry about these transformations, and there's a lot of them. So log 3 of x, this is going to be my parent graph. This is the one we are moving all the way through. So remember, x minus 2 moves it left or right. It's always opposite, so this one here is going to go right 2. So the first thing we're going to do is move our asymptote from 0 to 2. Okay, now we're going to take every point. So this one here is close, and we're going to move over 2. Now we're going to move our 1/3 over 2. And now instead of at 1, we're going to be at 3 because we added 2 to it. Instead of at 3 1, we're going to be at 5 1 because we're adding 2 to it. And instead at 9 2, we're going to be at 11 2 because we're adding 2. And there's your new graph. Now, how does this change my answers? Let's look. Oh, that's it. Okay. Now, these are tricky. This one reflects over the x-axis, and this one reflects over the y-axis. This one, you're just taking your log function, making it negative. That means everybody flips. So if we look at our log function above, which I hope you can see, so now instead of being at negative 2, you're going to be at positive 2 because you're changing your value. Okay, at negative 1, you're going to be at positive 1. At 1, that's 0, still going to be 0. Now you would have been at 3 1, so now it's going to be 3 negative 1. And then it would have been 9 2, so it's going to be 9 negative 2. You have reflected over the x-axis. We just took all of our y values and made them negative. We flipped their spots. So we're going to reflect over the x, the y values, change signs from your original. Okay, now the minus 2 means I have to move right 2. So I take all of these. So I'm going to, my final graph is going to be this green one. I'm going to move my asymptote right 2. I'm going to move every point right 2. So I'm just going to count 2 and put my dot. 1 2, 1 2, 1 2, and 1 2. And there is my completed graph, reflection and transformation. Okay, this one's a little bit trickier. So when you do this, I like to think of this as this, the log of negative x of 3. So what does this look like? So now, instead of all of my x's have to be negative in order to do the problem, So we're going to start at 0, 0 is going to be my asymptote. But now I can't plug in a 1 because I get a -1. All right, so we have to go to this side of my equation. So instead of 1/9, I got to plug in a -1/9 to get to 2. Instead of 1/3, I got to plug in a -1/3 to get to a -1. Okay, 0. We need to plug in a -1. All right, now at -3, it's going to go up to 1, and then at -9, it's going to hit our 2. I hope that makes sense to you. Okay, if not, get on Desmos and give this a shot. So my -x, all I did is I took all the points that were over here, all of these guys, and I made them negative. So I flipped it over the y. That's what we did here. Now, this move is tricky because this does not mean -2. This is really negative. You got to factor that out, x plus 2. That is what we're taking the log of, the negative of this graph. So this is technically moving left 2. So we're going to go 2 left. I should get another color. And we're going to put in our asymptote. Okay, so now we're going to move every point 2 to the left. So you're just going to take this point and move it left 2. This point, move it left 2. This point, move it left 2. Oops. This one 2, and this one 2. And there is your reflection and your transformation. I hope you did a good job. All right, stretches and vertical and horizontal stretches. Vertical stretches when the number's in front. All right, so the number in front, you're actually multiplying the y value, right? So we're taking the y values times 2. So if we go here, the y value is -2 times 2 is going to give me -4. So I'm down here. The y value is -1 times 2 is -2. 0 is still 0. Here, let's go here. Y is 1. Now it's 2. Y is, I don't have it on the graph. 9 would be 2. So now it would be way up here at 4. And that is your stretch. Vertical stretch. All right, so that's in front. You multiply the y values by this number. Okay, if it's inside, it's actually horizontal. So it's going to push it together. So we're going to take all the x values and divide by 2. So 1 divided by 2 is 1/2. So we're here. Now we had, this is 1/3 divided by 2. 1/6 is going to be there. And then here, halfway. Now we're going to go up here. 3 divided by 2 is 1/2. And then 9 divided by 2 would be 4.5. And that is your stretch going the other way. It pushed it together. I hope you did well. Those are kind of fun. Okay, let's keep moving. Okay, we want to graph. So pause and try all of yours. So now you've got x plus 5. So your base graph is log 4 of x. So you're graphing log base 4 of x. If you know what that is, type it in. If you don't, you're doing this one. So remember, we want to get to -2, -1, 0, 1, and 2. So this is 4 to the -2nd, 4 to the -1, 4 to the 0, 4 to the 1st, and 4 squared when we plug it into log base 4 of x. So 1/16 is -2. 1/4 is -1. 1 is 0. 4 is 1. And 16 is 2. All right, there is my parent. Again, your asymptote is the y-axis, or x equals 0. Now, this says I want to reflect my parent graph, and I want to move it left 5. So this is left 5, and it reflects. So since the negative is on the outside, it's going to reflect over the x-axis. So you're going to take all your points and multiply them by a negative 4, and then 16 would be negative 2. Okay, there's your reflection. Now I have to take all those points and move them left 5. So let's go to 5. Draw in your asymptote. And then these are very close to the asymptote at 1. Then we go 4, we go 1, 2, 3, 4, 5. 16 is going to be at 11. And there is your reflection and your transformation. Okay, this one, now he's reflecting over the y. Remember, this is really the negative x. So this takes all my original points and it moves them to all of these original up here and reflects them over the y. So they're now over here. So instead of 1, you're at negative 1. Here you're at 16th. Okay, so instead of 4, 1, you're going to be negative 4, 1. Instead of 16, 2, you're going to be negative 16, 2. There we go. We reflect it over the y. So this is my reflection. Now I need to move this, but remember this really means minus 1 times x minus 5. So I am moving right 5, which is right here. Now let's add 5 to every point. 4, 1, 2, 3, 4, 5, and 5. And that is both your reflection and your transformation. I hope you did a good job on your practice. Use decimals if you're getting stuck. Okay, the 3 in front means you are going to multiply the y value by 3. So let's put our original back in here. Oops, sorry. 1/16, 1/4, 0, 4, 1, 16, 2. Okay, so this red one is my original. Okay, let's go to a different color. Green. Now I have to take all of my y values and multiply them by 4. So 1/4 times 4 is going to, negative 1 times 4 is negative 4. Negative 2 times 4 is negative 8. Here we go, y value. 0 times 4 is still 0. 1 times 4 is 4. And then 2 times 4 is 8. Can't see these graphs. I need to make them larger. And right there is your stretch. Now this one, 3 of x, so we're taking our same points again. Let's put them back in. I'm drawing my parent. 4, 1, and 16, 2. Okay, there's my parent graph. Whoops, shouldn't have gone past that y-axis. Okay, now I have to take all the x values and divide them by 3. So 1 becomes 1/3. Oh my word, I'm not going to be able to get this in. Those are very tight. 4 divided by 3, we can do this one. 4/3, so 1 1/3. And then 16 divided by 3 is a little over 5. And there is my new graph. Almost looks the same as the other one, huh? I didn't do very well. I hope you did better. Use 2 different colors. It usually helps. Okay, now we're on to the last but not least stuff. Base 10. Okay, in your calculator, you have a button that's log. That is common log, and it means log base 10 is what it means. So when we use this on our calculator, log base 10 of x is the same as log of x. It follows the same rules, like right here. Log, that means 10 to the 0 is 1. This means 10 to the first is 10. This means 10 to the x is 10 to the x. These are your identities on both sides. So let's use here to solve a couple of problems. We know The percentage adult height for a boy who is X years old, so X is years, is represented by f of X, which is 29 plus 48.8 log of X plus 1. Okay, where X represents a boy's age, okay, the percentage adult height. Approximately what percentage of his adult height has a boy attained at age 10? So all we're doing is we're plugging in a 10 here. So in your calculator, we're trying to find f of 10, which is 29 plus 48.8 times the log of 11. Literally, just type that in, and your answer is 79.82% of his height at age 11. All right, the next one you need to know is base E. This is known as the natural log on your calendar. So every time you see natural log, you're thinking base E. So E to the 0 is 1, E to the first is E. These are your identities again, so they cancel to get X, and again, base E cancels to get this. You do not write the base E there, you are thinking that. So let's go here. We have outside temperature, 72 to 96. Temperatures in enclosed vehicle inclines by 43 degrees in the first hour. So the function, f of X, equals 13.4 times the natural log of X minus 11.6 tells us how much it has increased in an hour, or after X minutes. Use the function to find the temperature increase after 30 minutes. So I'm plugging 30 in for X. So after 30 minutes, how much has the temperature increased? 13.4 times the natural log of 30 minus 11.6. Literally type that into your calculator, and you should have gotten it increased 33.98 or 34 degrees in 1 hour. All right, good luck on your homework. I hope you're doing well. Remember to post questions if you have any.